Good morning, guys. You will need a textbook today, blank piece of paper, and please number those two handouts as 117 and 118. Alright, so we are now moving into our last major unit before we do semester test review and semester test stuff. Johnny, come in and sit down, please. All right, so in our last unit, we're going to spend a few class periods on rational functions and graphing of rational functions. But before we do that, we're going to do section 2.5, which is on the fundamental theorem of algebra, which we've kind of been touching on a little bit, but mostly just with quadratics. And for that, and for some other stuff in the graphing of rational functions, we need to remember how to do long division, how to do synthetic division, and making sure that we know when you can use each one. So that's what we're going to start off with. So I'm going to go over about half of this one with you, and then I'll ask you to go back and finish it up for some practice. So on this 117, I've got some questions where I'm going to have us do them both ways, both long division and synthetic division. I feel like it's beneficial to work both ways because then you can kind of lean on the method you feel more comfortable with as being your right answer. And if the method of the two that you're less comfortable with gets you the same answer, then you should probably feel pretty good about it. Okay, so we're going to look at long division for the first couple questions, and then we'll backtrack and talk about synthetic division. Okay, so long division is where you're going to take the divisor, m minus 8, and you've got to put that out front of the long division. So that's kind of the setup. You have to know how to write it. And long division is an algorithm, which just means it's got a couple of steps that we repeat as many times as we can. So the steps are, the first part of your answer, the first part of the quotient, needs to be the thing times this that gives you this. So you should be asking yourself, what times m gives me m squared? And that would be m, of course. Now, you actually take m and you multiply it to this whole thing. So m times m gives you m squared. M times negative 8 gives you negative 8m. Now, here's where, unless you have a better method that you are sure you're consistent with, this is where I would like you guys to take my advice and do what I'm about to show you. You're really supposed to take all of this minus all of that. Like you're subtracting the whole thing in parentheses. But students often forget that. They just subtract this one and then they add that one, which doesn't make sense. So what I suggest that you do, as soon as you're done multiplying, m times negative 8, change these signs and add instead. So every time you finish multiplying, and I'll do that in blue every question we do together today, and then that way you really are subtracting it, you've just distributed it right away before you forget. Okay, these two should add to 0, otherwise we didn't pick the right thing there. So m squared minus m squared goes to 0, and then use the rest of this in combined like terms. Negative 7m's plus 8m's would be 1m. Negative 11 plus nothing is negative 11. And then that's the entire algorithm. So now we just need to repeat it as much as we can. So I'm going to ask myself, what times m gives me m? That's the next part of the quotient, which is going to be the next part of my answer. I'm going to take that times m minus 8, put it down here. As soon as I finish multiplying, I'm going to change the signs and add instead. This should go to 0 if you pick the right part of your quotient. And then negative 11 plus 8 would be negative 3. So I went through the algorithm twice, and now we just need to know how to write our answer. So you probably remember back in grade school you did something, well, you wouldn't have done something this complex, but you would do something where you do the quotient, and then do you remember doing like r negative 3 as a way to say remainder negative 3? Okay, the reason that's not a real math thing. They did that for you because I don't think you even knew how to do, you barely knew how to do fractions at that point. So your answer should be the quotient, m plus 1, plus the remainder over the divisor. The divisor is the thing that you're dividing by. All of that is the answer. Now, if the remainder is 0, which happens fairly often, then that last term just goes to 0 and we don't have to keep up with it. We'd love for the remainder to be 0, but a lot of times it's not. Okay, so I'm going to say the exact same stuff on number 2, but just a tiny bit faster. So we need to know how to set up number 2. The n minus 6 goes out here. The thing we're dividing it into goes under the square root. And then this long division algorithm says the first part of your answer, the first part of the quotient, is the thing times this that gives you this. So that would be n. Multiply it to these, n times n times negative 6. My advice is to change the signs and add just right away, because that's pretty much the only place high school students mess up long division, is they'll remember to change the first sign and forget to change one of the later signs. Okay, and then add. These should go to 0, and they do. These combine to 5n, and negative 29 plus nothing is negative 29. Start the algorithm over. The next part would be 5, because 5 times n is what gives you 5n. 5 times negative 6 gives you negative 30. As soon as you're done multiplying, change the signs and add. Now, technically, long division, you could have to do the algorithm once or 2 times, like the last 2 questions, or 7 times. Like, you can do it as many times as you need to. But I know that I'm finished because there's nothing times n that gives me 1 without dividing by a variable, without dividing by n, which doesn't make sense. So we should be ready to write out our answer. Our answer comes from the quotient plus the remainder over the divisor. Okay, so I'm gonna have you practice I'm gonna have you try question 3 here in just a few minutes, but actually no, just go ahead and try it now. That's fine. Go ahead and try question 3. Set it up. Go ahead and do what you think you should do, and I'll go over it to help you catch any mistakes. Then we'll go back to question 1 and do the same exact questions, but with the synthetic method. Will you shut the door, please? There's a little loud up there. Okay. So, of course, make sure you set it up correctly. First part of your answer should be n, because n times n is what gives you n squared. You also have to multiply by everything here though, so also a 5n. Okay, and then most common place that you might have something wrong. If you have a 15 in here, you're falling into that trap that I was trying to tell you. You're really subtracting all of this from all of this. Or just distribute the negative, change the signs, and add instead. It should be a 5n plus 18 at this point, not a 15n. If you did 15n, you added the second part and subtracted the first part. Okay, next part should be 5, because 5 times n gives you 5n, but also 5 times 5 gives us 25. Same thing, change the signs and add before you forget. Looks like we end up with a remainder of -7. So, what we were aiming for on this question as an answer is quotient n plus 5 plus remainder -7 over divisor n plus 5. That's the divisor, the thing you're dividing into. Okay, so I will ask you to practice a couple more of those that we will check together. But for now, let's go back to question 1 and look at synthetic division. Okay, so exact same question as we did over here, but instead of long division, synthetic division. So I will tell you that synthetic division does not always work. Long division is the only one that always works. Synthetic division tends to be a little bit nicer for students, but long division is kind of like quadratic formula, where if you need to divide some polynomials like these, it's the only method that 100% of the time works. Okay, for synthetic division, it's got a different algorithm and a different start. So for synthetic division, most people make a little box and line like this. And in the box is where the divisor equals 0. So where m minus 8 equals 0. And then you need to list off the coefficients in order. So I've got 1m squared, then I've got negative 7m's, and minus 11 as a constant. If these were not in order, you would need to put them in order. If there was no m's, you better put a 0 for m's. Everything has to be in its right place. I've got 1m squared, negative 7m's, and a constant of negative 11. So a little more to its setup, but its algorithm just is a little bit easier for students. And this one's much quicker, so make sure you're paying attention here, you're going to miss the whole thing. For synthetic division, you just add down, so 1 plus nothing, and put it there. Then you multiply these two and put it in the next spot. So 1 times 8, and that goes here. That's the 2 steps, and you just keep doing it. Add down, multiply these two, and put it in the next little spot. Add down. You just do that until you've done it for every line. Now, the last thing with synthetic division is this is not our answer. This is telling us what our answer should be. This is the number of m squareds. So if I'm dividing out an m, I'm reducing the degree by 1. So it goes from a second degree to this is how many I have of the first degree, 1 m's to the first. The next number is going to be your constant, and your last number is going to be your remainder. So just like we did over here, you need to add the remainder over the divisor. And the divisor is not 8. 8 is just part of the setup. It should be the exact same answer that we get from long division. So again, I'm asking you to, instead of giving you, 10 long division and then 10 different synthetic divisions, I'm making them the same question so that when you practice some of these on your own today, you should be getting the same thing on both sides. And if you're not, then you know that you need some help. Okay, let me say that one more time, and then I'll have you try it on question 3. So, n minus 6, the divisor, equals 0 at positive 6. That's what I'm going to put in the little box here. I have to list off the coefficients in decreasing order. So I've got 1n squared, minus 1n, and a minus 29. Everything has to be in perfect position for synthetic. Again, if there was no n's, you have to put a placeholder of 0. Okay, but then the algorithm takes about 5 seconds to do the whole thing. Add down, 1 plus nothing, multiply these two and put it here. Repeat, add down, multiply these two and put it here. Add down, and then you just need to interpret this as your answer. So if I started off with n squareds, I divided out n's, I've reduced a degree by 1. So it's going from a second degree to a first degree. This tells me how many n's. The next number tells me what the constant is, and the last number tells me what the remainder is. The remainder still needs to be put over the entire divisor. Don't put it over 6. We're not dividing by 6. It's just, it looks kind of like that because that's what the setup is. Yes.
So if it was like 2n squared, for the first number we'd put a 4.
If it was 2n squared, you'd put a 2. Okay, so I've got that many n squareds.
Okay.
You're just putting how many you have. 1n squared, negative 1 n's, and negative 29 constants. Just however many there are. Now, if this was the same question, but let's say there was an n to the 4th, like all of this divided by n minus 6, then I would have to say I'm dividing by 6. I've got 1 n to the 4th, no n to the 3rds, 1 n squared, and minus 1 constant, or minus 1 n's, and a minus 29 constant. And then you'd have to do the algorithm a couple more times. But so you're just writing how many there are, not anything else. Okay, so try that, see how it goes with number 3. And I guess if you get the same answer I got on the left, you can go ahead and start question 4 on your own. Again, we're going to do we'll do one more of these together. We'll go over all of question 4 together, but I want you to try it on your own too. And then I'll have you do a few more on the back page later on in class. What?
Are you gonna discuss the next problem?
I am. What do you need?
No. I'll come back in a minute.
What do you need?
I was gonna talk to you about here. I was gonna ask you gave me zeros for assignments, but I haven't done the test yet.
Okay. I don't want to have to regrade it, so I put them in temporarily.
Oh.
But you should also have them turned in.
They are turned in right now.
Okay.
Right now.
Okay, but in the future you should turn them in with everybody else.
Okay.
Taking your test late doesn't give you extra time on the assignments.
Doesn't?
No.
I thought
Your
it did.
assignments are still due the same time everybody else's.
Okay.
You don't get rewarded by taking your test late. Unless you'd been absent or something.
But I was absent. What if I was absent?
When were you absent?
The day the test was taken. Was administered.
Doesn't have anything to do with the assignments before the test. Why would those not be done?
I don't know. Wait,
Well, me neither. That's why I'm asking.
If I turn them in right now, are they still gonna be zeros?
No.
Or they'll be like 5 or 10s or halfway? I'm just asking.
Less the more you stand up here and ask me.
I don't know.
Okay, let's check your work to number 3, unless you got the exact same answer. If you got the exact same answer, then it's right, because we know what the answer is, because we already did long division. You can ignore me and just start ahead on question 4. Okay, but synthetic division, the number in this little box up here, if you're going to, again, the box and this little line, I guess you don't really have to have those. It's just what people do. But this needed to be -5, the number that makes the divisor equal to 0. So where n plus 5 equals 0. The numbers you should have listed in the top were 1, 10, and 18. Because I have 1 n squared, I have 10 of the next biggest thing, and then I have 18 of the next biggest thing. And then the algorithm says add down. 1 plus nothing is 1. Multiply these two and put it here. Add down. Multiply these two and put it here. Add down, and you just repeat as many times as you need to. And again, this is not your answer. These 3 numbers should be pointing you towards your answer, but 1, 5, -7 is not the answer to this division question. We started off with n squared divided by an n, so it's reducing the degree by 1. So now this represents a number of n's, the number of the next biggest thing, which would be the constant, and then the number of the next biggest thing, which would be the remainder. Remainder always needs to be put over the divisor. Now, I haven't said this today, but I feel like you guys should know this. Adding a negative Adding a negative is really just the same thing as subtract. So if you'd rather make this minus the whole fraction instead of adding a negative, I'm sure that's how it would look on the ACT. They're not going to add a negative, but they're the same. So, okay, so try one more time for me. One more guided practice up on the board. So if you have not tried question 4 yet, I would like you to try it. And specifically, not just one more for practice, but this one doesn't have any A's. So I need to let you try and see if you know how to deal with that before we move on.
So I got a minus 5 and then a plus 5. And I can't see where I'm wrong.
Well, if you're adding these, 0 plus 5 isn't negative 5.
Oh. I
You
think
add
I'm
down.
subtracting. Yeah. Thank you.
And of course on number 4, if you're getting the same answer on both, they're probably okay. You can go ahead and move on to question 5 while you wait for everybody else. I do want you to go over 4 with us though, even if you got the same answer on both sides, just because it is possible to make the same mistake both sides. So okay, so the challenge with number 4, as you should have found, is in the setup for long division versus synthetic division. If you did this, this is not okay. Technically, it's okay for long division. For long division, this is completely optional. There's 1a squared, no a's. So if it makes you feel better, you can put plus 0 a's as a placeholder. But for synthetic division, if you don't put a placeholder, synthetic division thinks that this would be your constant, because it's the one to the far right, and this would be the next biggest thing. So this is like I'm dividing a minus 5 into a minus 28, which is not what I mean. I've got 1a squared, no a's, and then a constant of 28. So the 0 is optional for long division, not optional for synthetic division. So there's the setup for the 2. So long division, first part of your answer times a is supposed to give you a squared. So that would be a. A times a is a squared. Then a times negative 5 is negative 5a. And this might be where you want to put the plus 0a here, just so that you have a place to line it up. But again, technically, if you're careful about combining like terms, you don't have to do that. Change the signs and add. Next part of your answer should be 5, because 5 times a gives you 5a. Also 5 times negative 5 gives you negative 25. Before you forget, change the signs and add. So if you ended up with a remainder of negative 53, you forgot to switch the sign here at the end. You added instead of subtracted. So, all right, so in the end for long division, quotient plus remainder over divisor. A plus 5 minus 3 over A minus 5. All right, synthetic division, we should get the same answer, but just a different process. Different setup, but quicker algorithm. Add down, 1 plus nothing is 1. Multiply these two and put it here. Add down, multiply, add down, and then interpret these numbers. This would represent the number of A's. The next thing is going to represent the number of constants. The last thing is going to represent the remainder. Remainder still needs to be put over the divisor. You're doing the exact same question, just two different ways. So you should get the same answer both sides. But this is important. No placeholder on synthetic division. It's going to give you a totally different set of numbers, and you're going to have no idea that that's wrong. Long division, optional. But you can see it was kind of nice to have those line up. Okay, anything you'd like to ask about with number 4? Okay, I'm going to ask you to come back and practice the rest of this after we go over the other set of notes. But we're going to use this in some of the next stuff. Actually, pretty much all the new stuff I need to show you for the rest of the year is going to have some synthetic and or long division sprinkled in. So we need to practice that. But before we put this away, again, probably makes sense at the top of your paper. Again, this is not like just do whichever one you feel like. It depends. You need to know that long division always works, whereas synthetic, as much as you may hope that it always works, it only works when you're dividing by, I'm going to say x, but it could be a different variable like n. X plus a number or x minus a number. Like m minus 8 is fine, n minus 6 is fine, n plus 5 is fine, but if this was m squared minus 8, it doesn't fit this format. It's got to be a variable plus a number or a variable minus a number. That's what you have to divide by. You can't divide by quadratics and other polynomials with synthetic division. Okay. So for now, again, I do want you to practice the rest of those, and I will give you some class time to do that, but let's go ahead and move forward with the parts we need to do together. So section 2.5 is about the fundamental theorem of algebra, which I think I had mentioned the other day that you really probably know the fundamental theorem of algebra. You probably just didn't know its name. So the fundamental theorem of algebra just says whatever the degree of the polynomial is the same as its number of solutions, or the same as its number of zeros. That doesn't mean that they're all real zeros. Some of the zeros might be real numbers, some of them might be imaginary numbers, but whatever the degree of the polynomial is tells us how many zeros there should be. So as we look through these questions together, a quadratic has 2 roots, 2 zeros. A 4th degree is really going to have 4 zeros, 4 solutions. A 4th degree has 4 solutions. Now, when you move on and practice the book assignment, I tend to just make these blanks right away just to remind myself how many answers I still have to find. Okay, so if I want to figure out where this guy equals 0, so this is what we just did in our last mini unit that you guys tested over yesterday. I hope that it factors, just because that's easier for me, but if it doesn't factor, with the quadratic, we at least know we can do quadratic formula. Negative b plus or minus square root b squared minus 4 times a times c all over 2 times a. 64 minus 4 would be 60. 60 is probably going to break down. It does. Into 2 square roots of 15. Obviously, I'm not spending much time on this because we've talked about it recently. I'm just reminding you, solve a quadratic formula. 8, 2, and 2 are all divisible by 2, so I'm going to divide everything by 2. So 4 plus 1 square root of 5 and 4 minus 1 square root of 5. Those are the two zeros. Those are the two numbers that make that quadratic equation equal to 0. Now that's going to be important for us because even when we do 4th degree stuff, what we're really trying to do here is we're trying to rewrite this down to quadratics. Because if we can break something down to a quadratic, we always know we have this as a backup plan. Quadratic formula may not be your favorite, but if you can get it down to a quadratic, at least we know we can solve it. Okay, if it's not a quadratic, you cannot use quadratic formula. There are things like a cubic formula and a quartic formula that you could probably Google search if you wanted to, but I have a math degree and I never had to use those at all, so you'll probably never see them. But there are formulas out there for those, just not worth memorizing. So for us, we can't use quadratic formula. We would have to give you something that factors. So x to the 4th minus 16 is the difference of two squares. Anytime you factor, you always want to try to factor completely. And the x squared minus 4 is a second difference of two squares. It breaks down a second time. Whereas the sum of two squares does not factor more, but that's okay because we can still solve that. I guess you could do quadratic formula if you wanted to, but you don't need to do that on this one. But I know this equals 0 at -2, this equals 0 at +2, and this equals 0. I've got to do a little bit of work. I need to subtract the 4 over, take the square root of both sides, and what is the square root of -4?
2i.
Okay, and what happened to my 4th answer? It's a 4th degree. It's supposed to be 4 solutions.
2.
I already got 2.
-2i.
Okay, so right here, when you take the square root of both sides, don't forget you need plus or minus. So that's where I think laying out the blanks at the beginning will help remind you, oh wait, there's still one more. I need to find that. So again, in our last unit I talked about, how to store these. Your calculator has an I number button in there. If you store this in for X and you type this in your calculator and hit enter, it will give you 0. So you can check it that way. Okay, so question 3 looks kind of similar. It's a 4th degree. So again, can't use quadratic formula, so we would have to rig this to factor. And I'm going to try to get it with guess and check here, but again, product sum always works, just might take you a little bit longer. Let's see, 12 and 4 is not going to work. 8 and 6. I would do +8 and -6. Okay, that works. Now, this is not the difference of two squares, and this is not the difference of two squares. Unfortunately, these are factored completely. But they're both also fairly easy to just set equal to 0 and solve. Again, technically they're quadratic, so if you really want to do the quadratic formula twice, go for it. But since there's x squareds and not x's, it's a lot easier to just undo +8 with the -8, undo -6 with the +6, take the square root of both sides, not forgetting plus or minus, and simplifying the square root of -8, being able to rewrite that as 2i squared of 2. So one answer is 2i squared of 2, another answer is -2i squared of 2, third one is square root of 6, and the fourth one is negative square root of 6. All right, before we can do the next question, I have to tell you one thing, and if you don't remember this from algebra, you need to add this to the top of your paper. But right here, and technically up here too, you have to know that imaginary zeros, zeros with I in them, always come in conjugate pairs. So notice I've got a 0 plus 2i squared of 2 and a 0 minus 2i squared of 2. Remember, conjugate just means you're changing the middle sign. I've got a 0 plus 2i, which guaranteed that I had a 0 minus 2i. Imaginary zeros always come in conjugate pairs. That's important because in question 4, this is a 4th degree. I know it says find the remaining, but I'm just going to find all of them. I'm going to make a 4th blank and just say all. That's easier for me. Okay, they gave me one of them, 2 plus I. They gave me one of my 4 answers. And there is basically nothing you can do to move forward until you realize, well, this is an imaginary zero. Imaginary zeros always come in conjugate pairs. So 2 minus I is also a 0. Okay, now that we've got 2 of these, this question is kind of a pain, so you'll just have to hang tight here. But in theory, if I divide this 0 out, I can get this from a 4th degree down to a 3rd degree. And then if I divide this 0 out, I can get it from a 3rd degree to a quadratic. And I don't know how much of a pain the quadratic is going to be, but at least I know I could use quadratic formula as a worst case scenario to get the last 2. So you can't divide this out or divide this out with synthetic division. We have to divide these out with long division. Now, you could either divide this out with long division, get it in super messy work, then divide this out with long division, and it should all come out to be a nice looking quadratic for the last 2. But realistically, you want to divide both of these out at the same time. That's going to make the work a whole lot nicer. So, to change, let's add this. These are the zeros. You need to know how to change a 0 to a factor. And to do that, you just do x minus the 0. Minus and distribute. X minus a 0 is how you get a factor. If you have a 0 of 3, it means you had a factor of x minus 3. If you have a 0 of 2 plus I, it means you had a factor of x minus the quantity 2 plus I. Okay, so this doesn't seem very helpful to you, except we can multiply these together and then it's going to not look so messy. So let's multiply x minus 2 x minus 2 minus I and x minus 2 plus I. We're just going to multiply all this together. So x gets distributed to all 3 of these. That's going to give you 3 terms. Then you're going to distribute the negative 2 to all 3 of these. It's going to give you another 3 terms. And then finally distribute the minus I to all 3 terms. Everything here gets multiplied to everything there. And 3 terms times 3 terms should give you 9 terms. So you can see I've got 3 in red, 3 in purple, and 3 in gray to help you see where those are coming from. X distributed to the other 3, negative 2 distributed to the other 3, and negative I distributed to the other 3. That looks a little scary, but most of this is going to cancel out and go away. So notice we have a plus xi and a minus xi. So those are going to add to 0 anyway. We've got a plus 2i and a minus 2i, so those are going to add to 0. I've got an x squared. I could combine minus 2x and minus 2x to say minus 4x. And then what about this? Do y'all remember what I squared is?
1.
-1 square root of -1.
Okay, about half those were right. Okay, if the square root of -1 is I, if I square this side of the equation, then I've got to square this side of the equation. So what is this squared?
-1.
Right. So I squared is -1. If you don't remember that, you should probably jot it on the top of your page there. So this is really like +4 plus 1 minus a -1 is like +1. So those combine to be +5. So again, it looks kind of scary changing those to factors and multiplying them together, but then it cleans up really nicely. X squared minus 4x plus 5 is really the same thing as these two multiplied together. So to find these last two zeros, now we're finally getting somewhere. If I divide out that quadratic, I'm going to erase some of this to give myself more room. If I divide out that quadratic, it's going to expose this hidden quadratic, and that hidden quadratic is going to give me my last two zeros. This is why we needed to review long division before we got to this page. And as much as you may want to do synthetic division can't divide by x squared stuff. It can only divide by x plus a number or x minus a number. Okay, but same process. So it looks like if we get x squared, because x squared times x squared is what gives me x to the 4th. Then multiply it to this. Then multiply it to this. Change the signs and add. Now, we do have one really nice thing going for us that's about to happen. Is because these factors came from zeros, these should divide into it evenly. There should not be a remainder when we're done. So, again, this looks like a terrible long division question, but it should be just fine in like 5 seconds. Next part of the answer would be -4, because -4 times x squared gives you -4x squared. -4 times -4x would be positive 16x, and -4 times -5 would be -20. As soon as you change the signs and add, everything goes away and gives you a remainder of 0. As we knew it should. Yeah, what you got, Hayden?
It's -4. When you change the sign, it's plus 16x plus 16x. Right?
Plus 16x plus 16x. This one?
On the next one.
Down here?
It's because it goes to.
This would be 16x and then minus 16x.
But you're multiplying the 4x times -4x times -4.
Okay, -4x times -4x would be positive 16x. But then when you change the sign and add, it switches to a minus. That's why I say switch the sign. Because you're really supposed to subtract this whole bottom line. So now again, zeros go into it evenly. Factors made of zeros go into it evenly. You should know that you get a remainder of 0. Now, the whole point of that was, again, to expose this last hidden quadratic, and then we can solve that to discover the last two. So, I don't know. I really like this question type because it kind of shows you, you've practiced multiplying before. You've practiced long division earlier today. You've probably changed zeros in the factors. But you probably haven't had to do a question where you take seemingly random skills and be able to kind of combine them and to do something that you could do that you couldn't do otherwise. So again, the 30-second recap, they gave us 1 0, but they really gave us 2. Imaginary zeros come in conjugate pairs. You can change a 0 to a factor by doing x minus each one. If you multiply those two together, it looks nicer. Instead of saying these two messy things multiplied together, we could say x squared minus 4x plus 5. That was the point of multiplying them together. So when I divide these two things out, these two factors out, it's going to show me the other part of the quadratic that was hidden. And then once I had the other part of the quadratic, it was just a normal quadratic that I could solve easily. So that's what we were aiming for there. Okay, any immediate questions about 4?
Did you get that -4 on the top of the long division?
I needed a number times x squared to give me -4x squared.
Gotcha.
So that's how I knew it was. And again, y'all are going to practice more long division in a couple minutes. After we finish this handout, I'm going to ask you to go back and do the other. From this, you just need to see the big picture. Why am I doing long division? Not necessarily so much on how I'm doing it. Okay, let's look at number 5 here. So this one says find remaining factors. So I'm actually going to list out the zeros and the factors. To me, it's basically the same amount of work, but just kind of slightly different formatted. This time, they tell us x plus 4 is a factor. And if it was asking for zeros, one of the zeros would be where that equals 0. And notice, if I did x minus this, it would change it back to a factor. And they want us to find the other two factors. So this is just like the last question, but a much simpler version. If I divide out this factor from a cubic, it's going to leave behind a quadratic, and that quadratic is going to give me my other two zeros, my other two factors. Now, because this is an x plus 4, you can do long division, or you could do synthetic division. I'm just going to do synthetic division because I think it's quicker. This equals 0 at -4. I've got 6x cubes, 17x squareds, a -33x, and a -20 constant. Add down, multiply, add down, multiply, add down, multiply, add down. And once again, you're being told this is a factor. That means it divides into it evenly. Bless you. If you did not get a remainder of 0, you would know something was off. So, dividing out the -4, or the x plus 4, however you're looking at it, exposes this last quadratic, and this last quadratic is where I can get my last two factors, my last two zeros, just depending on whatever the question's asking for. -5 plus 1. So, factor with guess and check, or with product sum, but factored gives you the factors. If you needed the zeros, you could just set this equal to 0 and solve. You could set this equal to 0 and solve. You may also want to remember that real zeros, these are all three real numbers, show up as x-intercepts. So if you needed to sketch this graph, or if you were asked what the x-intercepts of this graph were, it would be these three. Okay, number 6, next to the last one here that we need to talk about on the board today at least. Find a third degree polynomial. So instead of you trying to find factors and such, it's trying to get you to come up with the function. So kind of backwards from what you're used to. Has zeros of 1 and 6 minus I. So if this is a third degree, it should have 3 zeros. 1, 2, 3. But they only gave me 2. So again, it's implied that you know the third one. Imaginary zeros come in conjugate pairs. If 6 minus I is a 0, 6 plus I has to be a 0. Now normally you have the factors and then you change those into zeros. This question's asking you to come up with the function. And not that you care to know this, but this is what we would do on a test. Like if we were coming up with this question, we don't just pick a random polynomial, work it, and then see what kind of answers it gets. We're going to start with what we want your answers to be. We're going to do x minus each of those. X minus and distribute. And then we're just going to distribute all this mess together, and it's going to tell us the function that would have those zeros. This is what it means by real coefficients. They want you to multiply all this mess together. So my advice would be to multiply the right two together first. Leave the x minus 1 alone, because these two are messy, and if you multiply them together, then they clean up pretty nicely. So just like the couple questions ago, x needs to be distributed to all three of these. That gives you 3 terms. Then -6 needs to be distributed to all three of these. Three more terms. And then the plus I needs to be distributed to all three of these. For a total of 9 terms. Now, I would combine like terms before you distribute this x minus 1 personally, because a lot of this is just going to cancel out. Xi minus xi goes to 0, plus 6x minus 6x goes to 0. I've got an x squared that has no one to combine with, a minus 6x, a minus 6x that could combine together. And then what about these two? What is 36 minus I squared?
37.
Very good, 37. I squared is -1. Minus -1 is like adding 1. 36 plus 1 is 37. And that's why I say multiply these two together first, because it's messy for a step, but then it's fine. All right, now we got to distribute one more time. So x needs to go to all three of these. Then -1 needs to go to all three of these. 2 terms times 3 terms should give us 6 terms. And now just combine like terms and we've got our answer. We've got an x to the third. We've got minus 13x squareds. We've got 49 x's and a minus 37. Now, you don't have to do this, but on longer questions like this is what I do to kind of keep up with stuff. I like to underline things as I combine them. So when I saw I had 1x squared, x cubed, I underlined it. When I combine the x squareds, I underlined them, and then that helps me remember what I haven't combined yet. So this is the function that would have those 3 zeros. So it's kind of backwards. A lot of times you start off with this, you use division to get it into factors, and then you set each factor equal to 0 and solve to get your zeros. This is just going the other way. Factoring is unmultiplying. It's undistributing, unfoiling. So we're doing the opposite process. Okay, and then the last one actually is not anything different, but this will be the one that I warn you about, just because students sometimes don't remember what these directions mean when it comes time for the quiz. But it's not any different skills than what we just talked about. This wants us to come up with 4 factors. Which are easy to make if we can come up with the 4 zeros. Because if you have zeros, just do x minus each of those and you've got the factors. This is not a quadratic, so like the first couple we looked at, that means it has to be rigged to be set up to factor. Always factor completely if you can. This does not. Now, This does not suffice as an answer, even though it's close to the directions, because these are not linear. These are quadratic. They want linear factors. So if I set this quadratic factor equal to 0 and solve, I get a couple of zeros. And by doing x minus those, I get their factors. And then I could set this factor equal to 0 and solve. Make sure you remember the square root of -1 is I. Plus or minus when you square root both sides. Also, imaginary zeros come in conjugate pairs. You can't have 0 plus I without a 0 minus I. And then do x minus each of those to change them into factors. And then there you go. Product means multiply. So show them multiplied together. These are factors. And they're linear factors. They're linear because the exponent on x is 1. So, again, I don't think we're doing anything differently mathematically, but that is probably one of the more common places students lose points on the next quiz because they're not familiar with those directions. So you might want to jot yourself a note in words there before we move on. Yeah.
For the second answer, is it x plus square root 6?
Yes, sorry. I copied it down too fast. There we go. Okay, so some factoring, knowing how to change zeros into factors, some multiplying together, remembering square root of -1 is I, square root, or I squared is -1. So multiplying together, maybe some synthetic division or long division, divide out a factor to find the others. Come up with them, divide out the ones you know to find the others. Fourth degree should have 4 zeros. Solve it with factoring. Fourth degree should have 4 zeros. Solve it with factoring. Second degree could be factoring or quadratic formula, but second degree would only have 2 zeros. So, all right. So you may get to practice a few questions from that today, but that's really not. You're not going to get all the way through all of that today. So what I'd like you to do first is go back and finish the long division, synthetic division practice to make sure that you're doing that correctly and get help on that if you need to. Because again, if you can't do synthetic or long division, you can start to see how that's going to mess you up. Maybe spend a couple minutes scanning those questions we looked at on the 2.5 worksheet. And you do not have to finish the book assignment today, but you should try to put a dent in it so that you don't have to do the whole thing next class. And I might be mistaken, but I think this is our last book assignment.
Yes.
Yeah, after the test, we're just gonna be focusing on preparing for the exam, right?
Yep. I'm
Yeah.
working on the semester
Final.
test review. Yep. But we got a couple more days of new stuff. Not a lot, but it's all from worksheets.
Oh, you just get that one. Yeah, I forgot to tell you about it.
When y'all get to the book assignment, you're not gonna know how to do question 15 and 16, so just skip those for today. It's not a hard concept or anything, but we can talk about those next time. What you need to do is worry about today's stuff. I'm not helping you with past things when you're not.
I was just curious.
All right, again, so just leave space for 15 and 16. It's not a hard thing. I just don't want, I feel like y'all got enough information for one day, so we can clean that up on Tuesday next week. But as you guys finish up the worksheet, again, if you're not getting the same answer with long division and synthetic division, that means something's wrong. Just bring it up here and I will look it over with you and help you make sure you got that cleared up. And again, just to be clear before I turn the screen off in a few minutes, you do not have to have the book assignment finished before Tuesday. I think you should have a good chunk of it done. Maybe close to half of it done, because you've got you still have over 30 minutes, but does not need to be finished.